Professor Colin, or would you like me to Colin? Welcome
Yeah,
to DEALITT
Colin,
podcast.
please, yeah.
Welcome to DEALITT podcast, where we like to meet the head of company, professors, scientists, and professional people like you. I'm really happy to meet you here today with your extensive experience in tunneling and geotechnical engineering and underground space. You have more than 35, 40 years of experience, significant experience in ground improvement, and you are the head of the CECL-Global consultancy. Colin, how are you doing today with this?
Yeah, I'm good, thank you. Sorry that my spaniel has just decided to get a squeaky toy on the floor.
No,
take that off him. Yeah, I'm very good at the moment, and we're very fortunate to be working on some really interesting projects at the moment. So yeah, really good.
Yeah, that's very good. Colin, you have a high experience in geotechnical engineering and research and industry, so, and also the innovation, mix of these three things. So how do you feel after this great achievement, long experience and remarkable experience? It's been long. I don't remember you.
You're right. It's been a long time. I started in the industry in 1979 at the age of 16. And
Wow.
By the time I was 17, I was fortunate to be looking after 6 tunnel drives on a small drainage project in the Midlands, and each one of those tunnel faces was a different ground type. So one was sandstone, one was shale, one was mudstone, one was running sand, and so I had a great introduction to the ground conditions. So and I know this might sound strange. In the early part of my career, I saw lots of tunnels collapse, and you learn a lot by watching instability. So I listen to engineers talk about the effects of water on ground conditions, and they don't realize that just a centimeter of water in a sand will cause instability. And when you see tunnels collapsing and daylight collapses, it's very informative. Thankfully, nobody was ever injured in these events, and I have to say that the standard of engineering now that we have in the industry, that there's has moved on immeasurably. So when I started work, I initially studied day release, and then worked on a number of projects until worked on one project which was particularly challenging, a compressed air project, a high pressure caisson next to a dock in Grimsby, which the shaft had previously blown. So this was a very scary thing to do. It was very it was very noisy, and it was very hot, and the pressure was high, and it scared me to death, to be honest.
Safety system,
So I thought this is a good time to go to university. So I decided then to go to university, and on the day that I went to university, they decided that what we were trying to do with the shaft was too dangerous, and they abandoned that solution. So but it was it made me go to university. Otherwise I probably wouldn't have gone.
That was a good time. So you had to go to university.
It was I'm a great believer in the butterfly effect. So one small event created a chain of events which completely changed my life.
I think so, and our life for the tunneling engineering, I think. Colin, if I start speaking about the time management and your interest in geotechnical engineering, I think time is really important, and you've been a director and consultant for many companies. So what is your advice for time management? How do you do it? How do you consult for time management for
Yeah, well,
underground?
that's
Yeah, that's a big question.
if anybody that knows me is what watches this podcast, they'll probably say I'm the worst time manager they've ever met.
Come on.
And because I'm easily distracted by things that interest
Yeah,
me.
busy. Yeah,
Having said that, I deadlines to me are sacrosanct. They must be met.
yeah,
And in the modern industry, whether it's my students at the university or in industry, I see time and time again failure being an option and
yeah,
failure to deliver something to the
yeah,
right standard or to the right time. And that just doesn't compute with me, that if you say you're going to do something by a certain date, it should be done. I have a great team. It's only a small team, but they're a great team. They're much brighter than I am,
yeah,
and so I get great support
yeah,
from that team. But I think if young people are listening to this, and the one thing I would say is if you say you're going to do something by a certain time, make sure you do it,
yeah, yeah.
and
Meet the
and just
target. Yeah,
yeah, you've got to meet the targets. And I am terrible at going off into the weeds of the detail or looking at the engineering of something. And only when the deadline is, absolutely upon me will I,
yeah, yeah.
I'm sure I have a mental disorder, which
No.
means I leave things to the last minute.
Well,
Um,
sometimes it could happen. Yeah, it works. It works last minute. Yeah.
yeah,
Mm.
but yeah, it's
Yeah, that's
and going back to my experience, I've been really fortunate that you say I work for lots of companies. I actually work for the same company, albeit changed its name a few times for nearly 40 years.
yeah,
And in that time, I looked after a design group of about 90 specialist tunnel engineers.
yeah.
And some people from the consultancy industry would call me a mongrel. So I'm half contractor, half consultant, and I
Yeah.
quite like that. I quite like
Yeah,
being a
different
mongrel.
experience. Yeah,
Yeah,
different.
yeah.
Yeah, yeah,
I also had a great opportunity to look over a lot of garden fences and see what people are doing, and just making
yeah.
connections between people with great ideas,
That's great. Yeah,
and also whether I was empowered to do so or whether I was flying under the radar. If we wanted to try something new, we just
mm,
did it,
yeah.
and
Take the
invariably,
opportunity. Yeah,
yeah. So we would work with organizations like the Building Research Establishment and with universities to test and trial new materials and new products. And
yeah.
never did they fail. Every time the client, sorry, I'm tempting fate now saying that, but every time we were able to deliver an improvement to a material or a process
They
or
take
to
the
some
advantage. Yeah,
equipment. Yeah. So it was, yeah, it's, and
that's really.
every day is a school day. And I know that's a cliche, but it absolutely is. I learn something
New. Yeah.
every day, and that's what I love the most.
Yeah, I think this is really the key from this point. Like every day we can learn something new. Um, Colin, I would like to ask you this question. Like you have extensive experience in tunneling, and everyone know that about you,
Yeah,
and the underground space and geotechnical engineering. If I can
yeah,
ask this question, why you're interested in geotechnical engineering? Why tunneling? I think it comes with time, but
yeah.
what make you really love this the
Uh,
subject?
I mean, I think I'm not alone that very few people enter the tunneling
Yeah.
industry and then leave it. It is an interesting industry, and of course, it's now the fastest growing sector in infrastructure.
Yeah, yeah,
So with the development of, we're now fast approaching 50 megacities around the world with over
yeah,
10 million population. We're running out of space. There's nowhere else to go.
yeah.
We're going to see new applications for underground space as well, and we're
That's
very
true.
keen to help deliver those solutions in a much more efficient manner, because
Mm, yeah,
major infrastructure projects in the UK particularly, and possibly around the world, they are not delivering best value to clients. And that's not because we don't have great consultants and we don't have great contractors. It's there are particularly the way in which projects are procured and managed. is suboptimal. And this is not just me saying it. You talk to the Treasury, the IPA, the major, anybody that's talking about efficiency of infrastructure will say the same thing. So we need to,
I believe so.
we need to fix this.
I would like to go through a little bit about some of the projects that you done. I can't mention all of them. It's very hard.
No, and I probably can't remember them all anyway.
Yeah, it's very hard to remember all of them. But some of the great projects that you involved, for example, the Channel Tunnel Rail Link, you've been working as a technical director for this project. It's called the project North Down Tunnel.
Yeah.
So it is the 3.2 kilometer project and use sprayed concrete line tunnel in weak rock.
Yeah.
So if I can ask the question, what are the challenges in this project? Of course, there are a lot of challenges. It's not easy project. Yeah.
Well, that project was one of the most enjoyable projects I've ever worked on. And in fact, if you speak to anybody that was involved with what was called the Channel Tunnel Rail Link, so now called High Speed 1, it delivered to an excellent standard, pretty much on time, on budget. In fact, I think the North Downs Tunnel was under budget.
Yeah.
And the budget for that project, built in 24 years ago now, the budget I think was 67 million pounds, and you look what you can get for 67 million pounds now, and it's not a lot.
Not a lot. Yeah, it's very
So there was starting with the design. One thing I should say is the reason it was such a great project is that the way in which the project was set up with the client's engineer, RLE, the designers and the contractors, they worked truly in a collaborative manner, and there was no duplication of effort. Everybody was adding value to the project and pulling in the same direction. And that was a really creative environment. So we were able to work with Arup and the client's engineers to value engineer the project, to reduce the lining thicknesses, to change the profile of the tunnel, all really successful. And so it was a great project. One notable exception, however, there was a very serious accident on the project. So one of our miners, so the method of construction that we were using was it was a tunnel in chalk being excavated with a machine called a road header. The rock is then scaled down, a shotcrete layer is applied, and then lattice girders and mesh are installed. During the installation during that operation, a very large block of rock fell on one of our miners, and they lost an arm and a leg in the accident. So it was very serious. Very, very, very sad. The health and safety executive, of course, examined and they basically asked a very simple question: why do the miners have to be there? And that was a very good question. So from that accident, we developed completely remote methods of construction, which are now pretty much the default for at least tunnels in the UK and in fact around the world. So, not having to use lattice girders for profile. So even in 1999, there were survey techniques which would enable you to remotely profile and control the shape of the shotcrete. So you didn't need lattice girders. If you could take the mesh reinforcement and replace it with steel fiber, you also didn't need to put people in to put the mesh in. So something good came out of something very bad. And
we learn from this.
Unfortunately, we do learn from our mistakes.
So if I can take it from the challenges, I would like to repeat the question a little bit in a different way. What lesson we learn from this project? I think you mentioned one of the most important part is the accidents.
Yeah. I mean, there's the technical learning that was made, but what we haven't learned, what we absolutely haven't learned, is to if High Speed 2 had been procured and managed in the same way as High Speed 1, it would be costing a fraction of the current cost. So in many ways, over the last 20 years, we've fallen into practices which are, the politest thing I could say is suboptimal. I used to
Yeah,
work with a great engineer from Arup, and she would always that was the phrase she would always use, suboptimal.
suboptimal. Yeah,
Yeah, and that goes for Crossrail, Tideway, High Speed 2, many projects. I
I
think
see.
I think everybody accepts that we need to find a better way of delivering
Delivering the
infrastructure, and it's not just
this
tunneling. It's
all the assets. Yeah, yeah,
yeah, yeah,
yeah. I see. I see. Colin, you have involved in as a technical expert and advisor for different tunneling projects, and for the government, for the UK government, for the contractors, for different projects like HS2, and also for Lower Thames Tunnel. For the Lower Thames Tunnel, as an example, of course, this is of course there are many other projects. There have been a lot of challenges, technical challenges, such as increasing the groundwater level, the geological challenges. So if I can take it as a question, what are the construction methodology and that been taken uh, to come up with this solution could
yeah.
be?
It's interesting that you've asked a technical question. In many respects, the technical challenges in our industry are the easiest ones to overcome.
Yeah.
The far greater challenges with these
Mm,
projects, as we've seen recently, is the so-called softer issues, the planning
yeah.
issues,
Yeah.
the procurement issues. Sorry, I know I'm like a stuck record with procurement, but there's something
Mm,
intrinsically wrong about letting contracts when you don't know what you're building, or you don't even know what the constraints will be.
yeah.
And so this sort of fast track approach, which has entered our industry in the last 20 years, and the justification being, well, you'd never start these projects, but
Yeah.
procuring on the basis of incomplete designs and incomplete thinking on methodology and planning issues is really suboptimal. And I can see a full circle going. I think we can go. I think we will go back to fully engineered
Yeah.
schemes being procured, and so
Yeah.
contractors know exactly what they're going to build. They
Yeah.
can price it honestly and fairly, instead of
Fairly, that's
playing games.
important.
As you know, I was a contractor for 40 years. I know exactly. Contractors want to win work, and so I think, yeah, again, sorry, I've come back to procurement, but the technical challenges, we've got great engineers in this country,
Yeah.
and great contractors. So actually doing the work, if you were to go to, I've kind of had a swipe at High Speed too. If you were to go into their tunnels and look at how efficient and safe
Yeah.
and sustainable they would be, it'd be world class,
Yeah.
absolutely
Yeah.
world class. That's not the issue. Doing the
Yeah.
work is not the issue. And you mentioned the sort of budget setting that we set the budgets for Lower Thames and Stonehenge and other projects. And people might be surprised to learn that the actual construction labor, plant, and materials is less than half of the cost of these projects.
Wow.
Um,
This
and
is
so you
really
might think,
surprising.
yeah, if you were building yourself a house, you might think, well, I've got so many bricks, I've got so many tiles, I need so many bricklayer hours, I need the mortar, I need the concrete, and you add all that together, and you might think that's how much your house is going to cost, and that's
Mm.
how much it probably would cost. If it was a major infrastructure project, you'd have to double it,
Yeah.
for all
Yeah.
for all the layers of
Mm.
management, for all of the inefficiency, for all
Yeah.
of the
Yeah.
change.
We do have
So
procurement issues. Yeah. Yeah.
yeah, yeah,
Yeah.
yeah. So
Yeah. I think
uh,
so. Yeah. It's not easy to solve it. Yeah. I think.
no, no. But in terms of the
Yeah.
sort of technical, there is one other point I would make as well about engineers. Increasingly, we're seeing uh, engineers coming from university, entering, particularly consultants, and being told that if you want to get on in life, you've
Mm.
got to go into management. You've got to become a project manager, and
Yeah.
and 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 go away from the tools, go away from engineering. I tell my students all the time, I've specialized and stayed in engineering, and
Yeah.
the benefit of that is I can sit across the table from anybody who wants to talk
Yeah.
rubbish, and I'll be able to call it out, and so I think, in my area of interest, that's
Yeah.
there's plenty of things obviously I wouldn't talk about, and so I would really encourage young engineers to because the time of the engineer will come. I think the
Yeah.
consultants will be looking around in a few years' time and just ask, does anybody know how to design this bridge or this tunnel or this? And they're all project managers. So I think there's got to be a good balance. And the great engineering companies, companies like Arup and Mott MacDonald, and they were based on really world-class engineers, and
Yeah.
that's what people around the world would buy, their
Yeah.
expertise. And
Yeah. Technical expertise. Yeah.
yeah, and
Yeah.
and I think we really need to value that again, and not just think that you have to be a
Project
project
management.
manager to
Yeah. I believe so. Technical expertise is really valuable. Yeah.
yeah.
I I would like Colin to speak a little bit about the risk management. Risk management for tunneling is changing with time, and you know that more than anyone. How do you see risk management improving during years with enforcing the CTM regulation for tunneling, for underground tunneling in UK?
Yeah, I mean, I think there's two parts. I mean, you mentioned sort of CDM regulation, so you're obviously alluding to safety. And the one thing I'd say is that I think I've worked with just about every
Mm.
European and British contractor, and I
Yeah,
don't think I've ever met I've never met an organization that didn't put safety first at
yeah,
the heart of their culture. So I don't think there's any.
yeah,
I've never seen either my own company or any other company, in fact, that I've worked with, deliberately cut corners on
mm,
safety. But risk management, I think we again have absolutely gone backwards.
yeah, yeah,
We have overcomplicated risk management to a point at which it's almost irrelevant
yeah,
to major projects. So um, producing Excel spreadsheets with with 100 columns with colors everywhere, but not proactively managing the risks is just a waste of
yeah,
time.
yeah,
So
yeah,
I was given a 5-star education in risk management after there was a collapse at Heathrow in 1994, and the client, British Airports Authority, brought in risk experts from the oil and gas industry.
yeah,
And anybody that knows the history of health and safety in the construction industry know that we learned a lot from the oil and gas industry, and the
yeah,
same with risk management. They brought people in, and they introduced me to the concept of formal risk management. And it's really just trying to, break the problem down, understand who's doing what, and then proactively managing it. And that's as simple as it should be.
yeah,
What we
yeah.
see time and time again is risk management just being an irrelevant schedule with numbers and
Excel
scores.
sheets. Yeah,
Yeah, but not proactively managing. So I
yeah,
on the North Downs Tunnel, I was the risk manager as well as technical director. We assigned about 3 or 4 risks to each individual, and every fortnight you had
mm,
to go and just say, what have you done with your risks? How have you proactively managed it? And even as the
yeah,
risk manager, I left, and perhaps because of my mental health issues, I left to the day before thinking, oh, damn, tomorrow I've got to say what I've done about these 4 risks. So I'd
yeah,
make sure that I did do something, because
yeah.
everybody's got their day job, and everybody'd say, oh, this bit, I haven't got time for this. And you don't need to produce lots of paperwork. You just need to make sure you're proactively managing it.
Yeah.
And
You
that's
consider it.
what,
Yeah, yeah,
yeah, and that's where the industry, I think, has lost the plot. The risk manager on one of our Crossrail projects, I went to see him once, and I introduced myself, and I said, you do realize that my team are designing all of the primary linings on this project, don't you? And he
yeah.
said, well, no, I didn't really know that. And said, and you've not assigned one risk to us, you know, uh, and
He forget
yeah,
it.
I didn't know that either. And I said, well, and it was just a complete and utter sham.
Yeah, yeah, yeah. It is.
So yeah, risk management is communication, understanding responsibilities, and proactive management, and it's no
It's
more
really.
complicated than that.
Yeah, I
Um,
think
and,
so. Yeah, I agree. Yeah, I think it's really important, as you mentioned, communicating the risk. Um, Colin, if I can ask this question in a different way, design, or I mentioned that the risk management change, and I want to ask also the design for that underground tunneling has been changed also during the years. So how do you see the design has been shifting during the years for the underground tunneling, and what research for the underground tunneling is still needed to to save the time and the cost for building underground tunneling?
Yeah, I mean that's an excellent question. Essentially, we dig
Yeah,
tunnels like stone age men
yeah,
and women dug tunnels. We scratch at the ground with things that wear out.
yeah,
And there's got to be a better way than that. So for years, as I've already mentioned, I've been really fortunate to have brought some new ideas and innovations to market. But the really paradigm shift things.
yeah,
So contactless excavation, how you excavate the ground without wearing your machine out, I
yeah,
think is a challenge. And also, yeah, and I would say this because we've just patented the system
yeah,
slip form, putting tunnel linings as an extruded slip form tunnel lining. We off and on, I've been working on it for 15 years. For the last 4 years, I've invested a huge amount of money, and we
mm,
believe we've got slip form tunneling to work now.
yeah,
Now, if assuming that I'm not completely insane, we think that that will reduce the cost and carbon of tunneling by 50%. So
yeah,
outputs, either relining existing tunnels or building new tunnels, using much more sustainable materials, so materials with very little reliance on Portland cement, but not but the same price as
this is really
existing tunnels.
interesting. Yeah,
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 because so many researchers, they'll look at exotic materials which are so
yeah,
expensive they're never going to be used in the real world,
mm,
and so we've developed equipment, and so for 4 years I've had a research project running, so we can now produce a structural lining instantly, so
yeah.
at the
That's
point
really
of
interesting. Yeah,
placement.
that's
So
really
it doesn't require any chemical setting,
mm.
and yeah, we're sure that this will, fundamentally change the way people look at
I think it's
tunneling.
really important. Yeah, I think it's
Um,
really
I mean,
important.
the,
Yeah,
the other big issue is public perception. So the public and clients, the perception is tunnels are really expensive. And the
yeah,
reason they think that is that projects where tunnels are used, like Crossrail, Tideway, High Speed 2, they
yeah.
are very expensive. But it's
Very
not because
expensive.
of the
Yeah,
cost of construction. It's not because of the cost of tunneling. It's all the other nonsense. So,
yeah,
and just as an aside, and you say, well, you're a tunnel engineer, you would say this. I got my master's students to look at a project. How much would it have cost to tunnel from Euston to Birmingham, high speed 2,
yeah.
all the way? And it was significantly cheaper than.
Wow.
And now the question is, would you want to be underground for 40 minutes? Well, people don't mind going on the Channel Tunnel for that distance, and
Yeah,
so all the costs associated, all the cost overruns, whether it's a surface tram system or whether it's a subsurface system, all of the costs increases are to do with the interfaces with the existing built environment and existing human beings.
yeah.
Digging
It's
a
very
hole in the
expensive.
ground is relatively cheap,
It's
and
really surprising. Yeah, it's really surprising
yeah,
how it's very expensive.
yeah, it's so
It's yeah.
if you may be aware that Elon Musk, and Elon Musk has said
Mm.
some strange things occasionally, but he challenged the tunneling industry to reduce the cost of tunneling by 90%. I think if you were to benchmark it against the cost of these projects,
Yeah,
I think it's not impossible that he could be, you could do it by
you
by
can do
using
it. Yeah.
new technologies, new materials. You could half the cost, and if you got rid of all the waste and inefficiency in the way that these things are being delivered,
Interesting.
and you can imagine, if you're a town planner, or you're looking at a strategic solution for a project, and you've got in your toolbox the means to deliver underground space very
Mm.
cheaply.
Yeah.
And this happens around the world. I mean, the
That's
Norwegians the Norwegians can tunnel
amazing.
cheap as chips.
I think that's
Anyway,
what we need. Um, I think you already starting a project called Benchmark for Highway England,
yeah,
and it's a starting point for this project that to aim to decrease the cost and sustainability for the underground tunneling. The aim of the benchmark tunneling for the Highway England is to predict the future for the underground tunneling in UK also.
yeah,
And and the outcome is to get it was a series of calculator to predict the tunneling underground project. So if I can ask you, what is the vision of this project and what is the challenges, what is the need? Yeah,
yeah.
yeah,
Well,
of course the
well,
need is clear a little bit. Yeah,
yeah. I mean, National Highways a number of years ago had the
yeah,
vision that they saw that their projects were suffering significant cost increases. And so
yeah,
they asked myself and my organization to come and look at how better value could be delivered, but also to do bottom up estimates. Because quite
yeah,
often benchmarking, if you want to know, how much should something cost, quite often they're top down benchmarking exercises. So you take the
yeah,
cost of how much did it cost to build Crossrail and then apply it to the next project. Well, in Crossrail was a commercial car crash. So
yeah.
why would you want to take the learning from that and just say, well, we're not going to get any better than that, so we'll benchmark against that. So they had the vision and foresight to say, look, we need a better way of doing this. Let's look at look at the design from first principles, look at the cost of each of the components. And you're right, we built two calculators. We built one meant for concept stage, which actually does the design of the tunnel for
Yeah,
you. You just put in a few simple metrics, and it will tell you the price, and also the cost of design, the cost of the personnel, the prelims. So, because as I say, the prime cost, the actual bricks and mortar, are sometimes a relatively small part. The commission was uh, an amazing commission because we were able to engage with industry
yeah,
and actually get the prices of everything from
yeah,
labor, plant, and materials. And what we've seen, and I saw this in my own company, the way work is getting procured now, contractors almost don't know how to price work anymore because they're
yeah.
not then they are not required to provide estimates. So on high speed 2, they were asked to provide a commercial commentary. So the
Mm.
client said, this is how much we think the job's going to cost. You provide a commercial commentary. Well,
They think, yeah.
what on earth is that about? And what's a contractor supposed to say?
So it
Well,
becomes
yeah,
a
we think,
prediction, yeah,
yeah,
more
yeah.
than.
I mean, they want to win the work, and of course they're going to say, yeah, I think you're a really knowledgeable client. You know what you're doing, and yes, it's about
Yeah,
right.
they trust the name
Um,
more than the calculation. Yeah.
yeah. So,
Yeah. Yeah.
so in my 30s and 40s, as the chief engineer of a construction company, and we were working on all design and build projects, I would do the design, and then I would sit with our chief estimator, and we would price the work together.
Mm.
And you're just thinking that, it's like falling off a log to me because this is what we've always done. But
Yeah.
now, the estimators are, they were of a certain generation, and the
Yeah.
industry has, lost a lot of those people that know how to,
Yeah.
know how to price work from first principles.
Yeah. It's a
Um,
shame. Yeah. I think there has to be a new method of teaching that new technology. I think
yeah.
it's very hard.
And I think that's why, if we go back to fully engineered designs, at
Mm.
least there's something tangible. There are drawings, there are things. When we used to price work, many, many years ago, the clients would issue drawings. We'd do a complete takeoff of all of the materials, send it to the suppliers, and the
Yeah.
suppliers would tell you how much everything cost, and you'd build a proper estimate. That's the way it used to be done.
That's
Nowadays, that just doesn't happen. It just on major
unfortunately,
infrastructure.
which
No.
increase the price. Yeah. Which increase
Yeah,
the
yeah.
price.
The price is no better than a guess sometimes. And the
That's
and
bad.
the and the risk allowances we're seeing on projects are just ridiculously high because contractors are there's so much uncertainty
Yeah.
that
Yeah.
they're just hedging their bets, and
And
So
needs are uncertain. Yeah,
yeah,
it's very sad. Colin, I would like to speak a little bit about innovation and achievement that you involved in, and there are a lot of achievements. I can't mention all of them, of course. You have involved in developing different technologies and construction methodology. One of them is the steel fiber reinforced tunneling lining,
yeah,
which has become a standard now in
yeah.
the industry. Can you take me through the process of developing this technique, and what are the limitations of this method,
Yeah,
if you can? Yeah.
again, excellent question. So in about 1994, we were working on a project at Heathrow baggage tunnel at Heathrow Airport, and this was at the same time that the other project, the Heathrow Express, was being built, and the Heathrow Express actually suffered that significant failure, and that I mentioned earlier. But on that project, in a design and build environment, we were able to introduce the concept of taking reinforcement out and putting fibre in. Now, my management team, I was relatively young then. They're saying, "Well, this is halving the cost of the tunnel lining.
Mm.
Are you sure? Are you sure this is going to work?"
Yeah.
And and basically they said in the review for the project, the chief executive of the company said, "If this is so good, why has somebody else not done it?" And that's
Yeah.
interesting question.
Yeah.
But the trigger for that was a simple book by a chap called Mark van der Walle, who just introduced to the tunneling industry a
Yeah.
book. The calculation was simple, even I could do it. And
Interesting.
and in many respects, I've been involved with writing codes and design standards for steel fiber concrete. And I would say that the industry, with the exception of probably a handful of people, still don't understand how to design steel fiber concrete. That it's got, they don't know how to characterize it, they don't know how to design it, and sometimes they don't know how to work with it. So
Yeah.
there's still, it's a great material, and it's, as you say, it's default on many projects.
Yeah.
It's not universally used, and one of our areas of interest at the moment is on very large tunnels. So for things like Lower Thames and Stonehenge, I know Stonehenge has just been cancelled, but for
Yeah.
those size of projects, using steel fibre on its own is not really a safe thing to
Yeah.
do, because the segments are too big and they're too thick. But I have spent 25 years trying to take steel out of underground structures, because steel and underground concrete just don't
Yeah.
go together. They're not durable.
I see.
And so we're working with a company who extrude GFRP cages, which we've demonstrated in tests at Rome University that there's really good compatibility between steel fiber concrete and GFRP bar
Yeah.
reinforcement. And so, there's never one size fits all. So I'm not
Yeah.
saying always use steel fiber, because if if you've got a really big tunnel in soft ground, you've got high bending moments, steel fiber on its own will never work.
Yeah.
But in combination with perhaps GFRP or basalt fibers and basalt bar
Mm.
reinforcement is also a great interest.
Yeah.
But we're very keen, for any of these things to work. You've got to look at the supply chain. You've got to look at the sustainability. How easy is it to get these materials? Who's making them? Where are they coming
Yeah.
from? Basalt reinforcement, the major source until the war in Ukraine was from Russia. So it's
Yeah. So
you've got to
quickly.
look
Yeah.
at these things, and
And the
we've done
factors.
some
Yeah.
we've done some amazing work with organic fibers, but there's only one supplier in the world that makes them in Japan.
Wow.
So, but absolutely amazing strain hardening material, self healing. If you were to test a beam of this material and bend it, or even in direct tension, and you put it in a water tank and then retest it, it'll crack in a different place the next time you test it. So, which is
Mm.
amazing. It's just, and that's why I think projects in the future, we just have to unthink our view of what concrete, steel, and even the ground, how we deliver solutions, because it's going to be completely different in the
Yeah.
future.
Yeah. I think the testing solutions and all of this part, yeah, is really
Yeah,
important. Yeah. It's a big topic, to be honest. Yeah.
Well, yeah,
Yeah.
and I mean, we haven't mentioned self-healing materials as well, and I think that's
Fuck.
a
That's
particularly for underground structures, the ability of a structure to heal itself is
yeah.
incredibly important. And
Yeah. I think it is. Yeah. Um, Coming back to the innovation, and we are still in the innovation topic. You have worked with the BMO tunneling company to develop different kind of solutions and technique. One of the solution is laser shell.
yeah,
How this technology changed the construction method and safety in tunneling from your
yeah,
perspective? Yeah. Yeah.
yeah, and it's good that you mention Bettina Moneybow BMO tunneling. That
Yeah.
we were first introduced to them in 1992
Yeah.
by a mutual acquaintance. So sprayed concrete tunneling was not really a thing in the UK in the early 90s,
Yeah.
and so we were joined with this relatively, they weren't a huge company, but a relatively small but very expert company from Austria. And
Yeah.
we the combination of their design and construction knowledge in spray concrete, and but also what we could bring in terms of process and safety and
Yeah.
materials engineering. It was a really good marriage. And the laser shell system was developed to build the tunnels in connection with Heathrow Terminal 5. So the Piccadilly line extension, the Heathrow extension, the Airside Road tunnel, and a smaller drainage tunnel.
Mm.
And the British Airports Authority they supported its development. They saw the benefit in terms of safety and
Yeah.
efficiency. And those tunnels were delivered, generally one pass spray concrete lining, so there were no waterproof membranes, or the ground was, in the west of London is pretty good. And now I'm involved with projects around the world where we see exclusion zones and people not going to the face because they're using remote techniques.
Yeah.
And so it has enhanced safety and efficiency. Now, having said that, the the there are a number of rules which have been imposed on the spray concrete industry, which have made it very inefficient. So
Uh-huh.
on Crossrail, for instance, the combination of multiple designers being involved in the process was one of the reasons that led to an overall thickness of the linings, which was extraordinarily thick, much thicker than it should have been. And again,
Ah.
anybody that talks about or knows about spray concrete design knows that we need to find better ways, because typical wastage factor for sprayed concrete on projects like Crossrail would be in excess of 2. So
Yeah.
when you're looking at the sustainability of sprayed concrete, you've basically got to assume that you're going to use twice as much concrete, and sprayed concrete currently has a lot of Portland cement in it, so it's
Yeah.
not a sustainable solution.
It's not the best
So
method. Yeah. Yeah.
yeah, so there are things that we can do to improve it. Much better design, much more efficient,
Mm.
and better ways of testing the quality as well.
Yeah. I think
But
it requires
yeah,
more research, I think. Yeah. Yeah.
yeah, absolutely. We're currently working. I mean, I'm associated with the University of Warwick. I work there one day a week, and it's great being able to talk to other faculties in engineering because
Mm.
I'm a passionate believer that most of the problems that we need to be solved are not going to be solved by civil engineers.
Mm.
So we're looking at things like laser speckled interferometry to look at identifying debonded and delaminated shotcrete, a major project around the world
Yeah.
on. So yeah,
It
it's
is. Yeah. A lot of
lots of
work. A lot of work.
lots of work. Yes.
Lots of work. Uh, I would like to go a little bit for one of the rules that you have many rules, Colin, around there. One of the rules that you involve in, which is a design manager for one of the manufacturing in UK. This manufacturing considered to be one of the best in the world, which is facility at Redham Dock in Kent.
Yeah. Yeah.
Can I ask you
Again,
why this manufacturing considered to be the best, and what was your role in that
yeah. No, that
designing?
that
Yeah,
that that was a really interesting departure,
yeah, it is. Yeah.
we set up that factory. In fact, British Airports Authority paid for the factory to be designed and built by my company to manufacture all of the segmental linings for the Heathrow project.
Yeah.
So so there and that proved to be very successful. We acquired the skills of a very expert, a small number, about 4 people from basically the team that had built the Channel Tunnel segments about 10 years earlier, and so we had some really expert people that we could sit down with and say, well, what does a factory look like today?
Yeah.
Now, the aspiration was to try and remove a lot of the workforce, so have a lot of robotics, have a lot of automation, and we achieved some level of automation, but we weren't able to reduce the number of so there was still a
Yeah.
number of activities which were done manually, which can lead to things like repetitive strain injury, and we produced a facility that could produce 700 tons of precast concrete a day. So it was pretty efficient.
It's massive. Yeah.
But again, I was able to work when we were designing the facility. I was being able to sit down and say, well, what do you want? What would good? If you would, you had literally a blank piece of paper, and we were able to engineer a carousel system, a concrete delivery system, a storage system, which was really, state of the art. And
I think so. It was really.
But there's no way I could have designed that facility without those 4 people.
It's a team working with it.
Yeah.
I think so. I would like to speak about the future research need. I think we mentioned a different research need, but you've been involved in different kind of project, Colin. But from your perspective, what research need to be highlighted for underground tunneling in UK? Significant research needed. Of course, you mentioned different research in this meeting. Yeah.
I mean, that's a very good question, and I am completely frustrated with the EPSRC and with the government that their investment in physical research is very small. So if you don't include the word digital and digital twin and BIM in your proposal, you might as well forget about it. But I'm very bitter and twisted. So that's why we funded our research ourselves, and because we failed so many times. But let's assume that things will change. I've already mentioned contactless excavation. At the moment, tunnel boring machines have come on, a lot, but they still, there are still major limitations with tunnel boring machines. And so looking at technologies, hybrid water jets, microwaves, lasers, all of which, if we look at microwaves, we at Warwick we've had preliminary meetings with the team at Nottingham University who are investigating using microwaves in mineral processing. So if you apply microwave energy to a rock, because of the different minerals, it will create thermal tension and basically weaken and soften the rock, and therefore reduce the energy you need for mineral processing. So we met with Professor King at Nottingham University, and we said, well, what about contactless excavation or contactless demolition? And his response was, well, we've not thought about that. It's a great idea, but nobody's looking at it. And if you actually start looking into these things, you find that there's nothing new on heaven and earth. So thermal drilling has been done in Russia with simple diesel lances for quarrying for over 120 years. The use of the use of lasers to drill holes. 5 years ago, the front page of the American mining magazine basically said conventional drilling will be dead in 5 years. And so I think these new technologies, I mean, there's a hell of a lot of work to be done with these things. And even if they were to, we talk about contactless excavation, even if it would just to aid the excavation process, that would, there could be some benefit. Reduce tool wear, and I think we're looking at new materials all the time. Friction, looking at the friction of materials, the hardness of materials to prevent them wearing out, and of course the major sustainability challenge is getting rid of Portland cement. And what I'd say is, pretty much 95% of articles and research that you see about sustainable concrete relies on PFA or slag. So you've got to either make steel or burn coal to make this sustainable concrete
material.
So we have actively steered away from relying on those two. They're currently called byproducts. We think will probably be reclassified as co-products, and will have a proper amount of carbon associated with them in the future, or they should do, because it's disingenuous to say that they're carbon free.
I think so.
But
I think I have a lot of questions.
Sorry, just one final point. The sustainability of that in terms of getting the material. So, slag is being brought from Japan and PFA from Spain at the moment. So there's just not enough of it in the world to make sustainable concrete. So we're looking at using calcined clays and the much more sustainable materials, which is emerging technology.
It's really interesting technology, I think so. As a sustainable material, geoscience. Colin, if I can, I really have a lot of questions, but I can't ask a lot. But we need to stop at some point.
I have no idea what the we're probably about an hour over time.
Colin, if I can ask the final question, please. What is your advice for engineers who are interested in tunneling engineering and in this subject? It's a lot,
to apply for the apprenticeship or the master's program at the University of Warwick, which is going to restart next year. You may be aware that we ran a master's program up until COVID, and it died during COVID. But we're hoping to get approval for a level 7 apprenticeship in the next few weeks. And Warwick and Birmingham University will be offering that apprenticeship, and the benefit being that it's a part-time course. It doesn't cost the employers anything other than time, and the students don't have any debt from that course. So but on a more global advice, stick to engineering. Just be interested in engineering, because your time will come. If
I think so. That's great advice. That's a good advice. Colin, please thank you for your time for this set with our podcast and DEALITT podcast, and thank you for the opportunity, and thank you for your contribution. And I hope I can meet you another time in different sets.
That would be great.
That would be really great.
And thanks for the great questions.
Thank you, Colin.
It's been great therapy for me.
Thank you, Colin. Thank you very much.
Thanks.
Hopefully I can meet you soon. Thank you.
Thank you. Bye-bye.